Hello and welcome to Industrial 5G Uncovered. I'm Linda Ligio, Senior Innovation Partner at Digital Catapult, the UK's leading innovation centre accelerating the adoption of advanced digital technologies. I'm delighted to be your host for today's event, which is the second of a four-part series that aims to explore 5G innovation in manufacturing logistics. And we're doing this by inviting to this very virtual stage some of the innovators and industry experts who are at the forefront of 5G adoption. And those are the people who have joined some of the most exciting R&D programs within and beyond the UK to demonstrate the real-life impact of 5G as an enabler of digital technologies. And we're talking about technologies such as artificial intelligence, robotics, digital twins, virtual and augmented reality, and more. Just to let you know that this webinar is recorded, and if you have missed our first webinar, don't worry, you can still watch it on our YouTube channel. And I'm also delighted to reveal that our next webinar will be on the 18th of January, where we will share learnings from the first wave of industrial 5G deployments. So the registrations are open, so do sign up now. But next, for now, let's have a look at what we have in store for you today. Shortly after my introduction, we will hear from our Director of Market Development before we run through a series of short presentations showcasing some exciting use cases in manufacturing and logistics. We will then move on to a panel discussion on how 5G can accelerate digital transformation, and we will conclude today's event with a networking session on a platform called Remo, for which you should already received the links. But if you haven't, don't worry, we will share it again later today. So I've mentioned R&D, and this is one of the things that we do at Digital Catapult, but also one of the main reasons why we are here today. And it's because we have partnered with the Department of Culture, Media and Sport to coordinate the Industrial 5G Testbeds and Trials program. This is the UK's first large-scale R&D program experimenting with the next generation wireless technology to tackle Industry 4.0 use cases. We've been working with 8 projects since early 2020 to help them solve common challenges, but also to try to elevate single outputs to facilitate sector-wide knowledge and learning. You can see here some examples of some of the use cases that has been explored by the projects. For example, from immersive technology to support remote expert assistance to digital twins. And although today we can only offer you a quick snapshot because some of the trials are still in progress, we are consolidating learnings in the form of digital resources to help you navigate this complex landscape. And we are delighted to share with you today the first edition of the Industrial 5G Innovation Toolkit. This is a practical and interactive resource which contains information about real-world case studies. There is a 5G glossary and also an ecosystem mapping to help you identify useful companies in the supply chain. And now it's time to talk about the role of the 5G can play in facilitating digital technologies. And I'm delighted to introduce you to my colleague, Nick Wright, who's the Director of Market Development. Nick, hello, welcome, and thank you for joining us today. I'm going to let you do a little introduction and I'll see you later on. Thank you.
Morning. Thank you very much, Linda, and good morning, everyone. As Linda mentioned, my name is Nick Wright, and I look after our industrial markets at Digital Catapult. One of the things that's really interesting about industrial 5G is how it relates to industrial digitalization and the wider Industry 4.0 theme, something that's been around for the last 10 years, but adoption has been much slower than anticipated in the UK. Now, obviously, we've had some huge headwinds, such as Brexit and COVID and various other things that have affected manufacturing and logistics. But a survey by Make UK earlier this year said that many people in the manufacturing sector see a huge opportunity for innovation, and it's still top of the agenda. So great signs for us to potentially move forward. Now, industrial 5G connectivity has been specifically designed for industrial applications and the different kind of use cases that Linda just mentioned previously. Back in July 2019, Digital Catapult published a report called Made in 5G that was really looking at what are the technical capabilities and opportunities of industrial 5G, and really what the industry see as the barriers to adoption. Now, top of this list was classic industry 4.0 challenges, things like return on investment and defining the value of the technology, understanding the costs involved, kind of knowing where to start in the first place, who to talk to, what are the skills that we need, the security implications of these networks, and then more broader topics like the culture of a company with big kind of changes and the impact of stopping production. Now, I mentioned that these are all common barriers with Industry 4.0, but 5G is seen by us and the wider ecosystem as a really key enabler to removing some of these barriers and trying to accelerate industrial digitalization. The Industrial 5G Sector Testbeds and Trials Programme that has been funded by DCMS has really been addressing directly some of these barriers. And the toolkit that Linda just mentioned is a really, really fantastic resource to answer a few of those. So firstly, kind of knowing where to start, looking at the skills and the different kind of people, and is just starting to build on the return on investment and costs of some of the equipment. Digital Catapult has also been doing some work. So we have a strategic partnership with Ericsson, and we published a couple of case studies with them last year that were looking at that return on investment question and what the opportunity for this kind of technology is. We've also got some other initiatives that have gone on. So the Digital Security by Design program that's funded by UKRI's Industrial Strategy Challenge Fund is something that's looking at the security aspects. And then we have other programs. So for example, in Bristol, the National Composites Centre are running the DETI program, which is looking really at the digital engineering side of how these technologies work together. So there's a lot of different kind of resources that are out there, facilities and test beds to develop these applications. 5G is still in its early stages and we're still testing and developing them. But what we've done in the UK is get ahead and building that infrastructure to allow us to develop these more. But what does that look like in terms of future funding and future opportunities? Well, more broadly, we've got a really key alignment with the Made Smarter program here, and specifically Made Smarter Innovation. And this is something Digital Catapult has been working really hard to do to try and figure out how we can align these two initiatives from DCMS and through Made Smarter Innovation. The Made Smarter program has funded a whole range of different kinds of fantastic facilities. So we have a number of research centers. We have the KTN Innovation Network. There's a couple of innovation hubs that are starting to launch and plenty of CR&D funding. And the current opportunity that's around, there's just been a call opened for sustainable smart factories, which seems something very akin when you look at and listen to the presentations today. You're going to hear about how sustainability is really at the core of what many of these projects are trying to do. And that call is open until the end of January and provides a fantastic opportunity to help develop and scale and address some more of those barriers. So with that, I'm going to hand back to Linda, and please enjoy the rest of the event, and I'll be around for the networking event at the end.
Thank you very much, Nick, and thanks you, for telling us more about funding opportunities. And there will be more that you'll be able to find out later when you join our networking session. But now it's time to talk about how 5G can boost manufacturing logistics. And I'm delighted to introduce you to our speakers for today. They come from both the Industrial 5G Testbeds and Trials program, but also Horizon 2020. And today they will give us a brief overview of what the project have done, or actually are doing, but it will be very brief. But don't worry, if you have any question, you'll be able to meet them later on in the networking session. So without further ado, it's my pleasure to welcome our first guest, Oliver Swift, who is the Manufacturing Development Team Leader at BAE Systems. Oliver, please feel free to join us in our virtual stage. Hello.
Hi, good morning.
Thank you for joining us today. Please feel free to start sharing your screen. Thank you.
Thank you. Good morning to everybody who's joined the webinar, and thanks for the introduction, Linda. As you mentioned, I'm Oliver Swift from BAE Systems. I'm the 5G technical lead for the 5G Factory of the Future program, and one of the technology capability delivery team leaders. 5G Factory of the Future project brings us together with research organizations, network and technology providers, and manufacturing SMEs to create a testbed in the Northwest. Next slide, please. Joining the DCMS 5G Create program, our 5G testbed will output proven and industrialized architecture for deployment into production environments by outlining a series of 5 proof of concept scenarios. The use cases are addressing a number of manufacturing challenges seen today, as well as future challenges we anticipate, and identifying how we can leverage the 5G technology, including the big data, low latency, and high bandwidth. The 5 use cases are along the bottom. We've got real-time RTM, which is real-time monitoring and closed-loop control of a machining process. By streaming variables in real time, the intent is to intervene by way of stopping the process before a defect occurs, or adapt and control the variables to ensure extremely tight tolerances are adhered to. We've got digital twin. This will create and prove a reference architecture for our digital twin and 5G, and enable scenario mapping with the ability to simulate real life situations by using historical data to predict behaviors in the process, but also using the 5G and the digital twin to optimize factory layout and flow. We've got FEM, which is the factory ecosystem monitoring use case, which I'll go through in more detail in the next slides. The chain of custody use case, which is monitoring assets through the life cycle from supply to customer. It's conditional and location monitoring, giving real-time notifications to the relevant stakeholders in real time. And HRS, which is mixed and shared hybrid reality spaces, which again I'll go through in the next slides. Next slide, please. The factory ecosystem monitoring is designed to sort of understand our processes. At our Wharton and Salisbury sites, we have world-class manufacturing facilities. And in the past, products ran for 20 to 30 years, and bespoke systems and infrastructure was the most advanced and cost-effective way to produce the product. The future landscape, however, is looking a little bit different, and it's simply not sustainable. We're positioning ourselves to address the future needs of the customer. The FEM use case will see wireless connectivity, enabling agile and product agnostic assembly systems, a sensor network monitoring cell performance, as well as internal and external environmental variables, visualization and process optimization via wireless data streaming and massive machine type communications, enabling agile and reconfigurable manufacturing systems, and a degree of robot autonomy enabled via data streaming, machine learning in our robot assisted assembly cell. The goal here is to reduce infrastructure requirements, changeover times, and operational costs. Next slide, please. And distributed and shared hybrid reality spaces. So streaming data across the 5G network, connecting mixed and augmented reality to unlock CAD-assisted maintenance or assembly. With the use of wearable technologies and immersive technologies, CAD models can be streamed across a 5G network and overlaid on the product being assembled or maintained, and provide point of use operational planning. We can use it for remote inspection or assistance. Some aerospace inspection processes require one technician doing the maintenance and then waiting for another delegated professional to inspect the work. There can be huge time, travel, and cost savings if these two tasks are combined. And collaborative CAD editing. The current way of sharing 3D models is to duplicate the model in all of the end nodes on the network. This gives us a problem in having multiple sources of truth, and it can create conflicts during collaboration, particularly when sharing and editing high resolution CAD data. We're going to be using enhanced mobile broadband, allowing the network to be reliable and secure with high bandwidth connecting multiple sources of information. Next slide, please. And I'll wrap up there and hand back to the Digital Catapult team. Thank you for listening. I'm happy to take any questions in the Remo session following the presentations.
Thank you very much, Oliver. And thank you for sharing. I mean, there are so many use cases, so I'm sure you've been very busy, and the project will continue doing the trials until the end of March 2022. Thank you. So we're now moving from smart factories to autonomous logistics with 5G Cow. And to tell us more today is Richard Barrington, who is the Business Development Director at Perform Green. Hi, Richard. I can see already your slides. Please start sharing your screen, your video. Thank you.
Hi, good morning, everybody. My name is Richard Barrington. I'm the 5G workstream lead, a bit early in the morning, for the Connected Autonomous Logistics project at Nissan. And what we're doing is building a 5G infrastructure to allow us to remotely operate a 42-ton HGV. The challenge is with autonomous logistics is once there isn't anybody in the cab, the vehicle can become redundant or stranded if situations arise. So the principle behind the project is for us to be able to take remote control of the vehicle and drive it safely either to a point that it needs to go to or to restart and so on. And this, of course, has massive implementation capabilities across a whole range of market sectors, because obviously, as soon as we take the safety driver out, we then have that challenge. And so, but that's also the major cost saving and benefit for this. So the idea is that we're actually not just building this facility, but we're also developing what we believe will be a test bed for the whole of the Northeast or for the whole of the country. That we start with a test track, we have private road network, and then we can go into the public realm. So as you can see here, we've plotted a test route or trail. Sorry, I should say trial route. I meant to change it. Down the bottom of the slide, that is the Vantec distribution facility, and at the top where you see the red pointer, that is actually the Nissan trim and chassis building. And around 100 HGVs a day move goods between these two locations. And so what we are doing is turning that into an autonomous route and running all of the tests and trials to achieve that. And the way that we're doing it is we've built a 5G network using the Ofcom shared license spectrum. We've actually built a standalone 5G network, so we're really ahead of the curve. We needed some features of that to make this successful. So we are seeing roughly 10 milliseconds latency on the 5G network. So the vehicle broadcasting data across the 5G network to the teleoperator and back again. So the teleoperator is actually driving the truck remotely. The overhead from the network is less than 10 milliseconds. The other big difference to most normal networks is we needed 100 meg uplink because obviously we're transmitting a huge amount of data from the vehicle. And so working with our systems integrators North and Nokia, that's exactly what we've constructed. A network that's kind of flipped on its head. A normal 5G network or normal wireless network is massive downlink, small uplink. We flipped that because that's the only way that we could actually get the data from the vehicle that we needed to. We've also extended the network into SASME. SASME is a facility about advanced manufacturing. Driving the Electric Revolution is going to be is moving in at the moment and putting in a production line, and Nissan are using that for their test facility for a number of applications on the net. So it's not just about the logistics piece. We're also doing some more in the manufacturing realm, and we can talk about that if anybody wants to when we meet later. So where we are is we have the autonomous software, which was developed using an electric vehicle, the test mule, and we've driven that around the site, and then we've validated all of the metrics. We've then done detail verification and simulation, so we're actually running using the autonomous software, and we've acquired our test mule, which is a Terberg, and it's an electric vehicle. And that's what we'll be doing the final testing in. You can see the cameras and the LiDAR sensors on the roof of the cab. And of course, we'll also have something at the back of the vehicle as well. So we are well into the testing phase, and results so far are looking really good, really positive. And the teleoperation, you can see the screen down there. We're still in the final design of the actual unit itself. But you can see there the view from the teleoperator as they are driving the vehicle remotely. We have a maximum speed on site of 20 kilometers an hour. We've got up to 8 so far, but everything is working as scheduled and as planned. So that's all looking very good. And again, happy to talk through this as we meet later on. So the idea very much is that we have the test facility. So we have a test track where people can come and test their experiments. And then we can go into that private road network that I showed you earlier, which is several kilometers. And then eventually we do have expansion into the advanced manufacturing park, which will give us a much larger footprint. So we can test all of this and make sure it is safe as we deal then with the political implications and legal and insurance implications of autonomous vehicles. So thank you very much for your attention. If you want to get in touch with me, that's my email. This is the partners. It's a broad spectrum of organizations that have come together to deliver what is looking to be a very successful project. Thank you.
Thank you very much, Richard. And we will hear a little bit more about 5G Cal in the panel discussion. Next, we are actually virtually crossing the North Sea and connecting with Sweden, where we have Dr. Lefke Grosjean, Senior Researcher at Ericsson. Hi, Lefke. Thank you for joining us today. I believe you're going to tell us about 5G Smart, which is a project from Horizon 2020. Over to you. Thank you.
Yes, thank you very much, Linda. As you said, my name is Lefke Grosjean. I'm a senior researcher at Ericsson and project coordinator of 5G Smart. And today I would like to show you a bit what we do there, but also give you some few insights about our learning so far. So 5G Smart stands for 5G for Smart Manufacturing. And on this slide, I'm showing the overview of the project. Ericsson and ABB are coordinating this project together. And from the logos on the bottom of the slide, you can see that we have a very strong and diverse consortium with partners from ICT, OT, network operators, factory operators, academia, and so forth, really bringing together the entire manufacturing ecosystem. So what do we do in 5G Smart? We're starting from the top here. Our first main pillar is research and concept work on the integration of 5G in the manufacturing ecosystem. Here, we've been dealing with the analysis of potential new business models in the emerging ecosystem. We've looked at the value created by 5G for factory owners, and we've been running extensive simulations to evaluate different deployment options. Then we have the second major pillar of the project, and that is on demonstrating, evaluating, and validating 5G capabilities in industry field trials. And I will say a bit more about these trials in the coming slides. So for now, I would jump over to the third main pillar of the project. Here we look into enhancing 5G for smart manufacturing, and this is again concept and research work. We are exploring new 5G features, analyzing 5G TSN, time synchronization, positioning, but also touched upon new network architectures, edge computing, network management, and so forth. But with that, let's have a closer look at the trials of 5G Smart. This is the first trial that you can see on this slide. It's inside an Ericsson Smart Factory in Kista in Sweden. And we are exploring novel approaches of industrial robotics enabled by 5G here. At this site, we're featuring 5G connected collaborating robots, ABB robots, a stationary and a mobile one, that are interacting. And the challenge here is that the key functionalities that are on the robots are removed from the robot device itself and into the edge cloud instead. We also have human workers on the factory floor that interact for specific tasks with the robots and may use an AR headset to visualize information from the factory floor. All of the use cases make use of the local edge. And one of our major learnings here is that this shift from the device to the cloud has massive advantages. It is feasible with 5G, and it is something we expect to see more and more in the future. You can see here on the left, we have an intro video to this trial. We have also introduced intro videos for our other trials, and you can find them on the website if you follow the link here. Let's move on to the second trial of 5G Smart, and this one is inside a 24/7 fully operational semiconductor factory at Bosch in Germany. We look into 5G for factory automation and intralogistics, partly focusing again on robots, but this time looking more into logistics and the use cases arising when having many mobile robots on the factory floor. So we have a research mobile robot here that we have built up from scratch and which has basically all of its functionality moved into the cloud. And this allows now, for instance, the mobile robots to have a common map that is updated in real time. And from our first use case execution, we can actually see how this 5G enhancement makes it possible to perform tasks in the factory much more efficiently. For instance, mobile robots are avoiding each other much more efficiently. So that's a great learning. Many more activities at this trial site, but I will jump over to the next trial site that we have. And this site is inside the shop floor of the Fraunhofer IPT in Aachen, Germany. And here we have the focus more on process automation and process monitoring. And we're looking, for instance, into how 5G can support wireless tool condition or workpiece monitoring. For instance, trying to detect that a tool is broken during the machining process. Another work stream is on the development of a multi-sensor platform to which different sensors can be attached and that can then be used to monitor processes on the factory floor. Our results and learnings from this site show that wireless monitoring of critical processes is possible with 5G, and the related applications bring great new possibilities to the shop floor. That was all from me at this point. Back to you, Linda. I hope everyone got interested in the project, and I'm looking forward to the networking session.
Thank you very much, Lefke. Thank you for this brief overview. And now we have another project from Horizon 2020. And to tell us more today, we have Nuria Molnar, who's R&D engineer at the Polytechnic University of Valencia. Hello, Nuria. Please join us in our virtual stage.
Hello.
Hi. Hi, Nuria. Thank you for joining us. Feel free to start sharing your screen. Thank you.
Okay, I'm going to present Ingenious project, which is an Horizon 2020 project and composed of 21 partners from all around Europe. The main goal of Ingenious is to digitalize and automatize the supply chain by integrating next generation IoT solutions with emphasis to 5G and edge and cloud computing. In order to do so, the project has defined 6 use cases that aim to cover all the main steps of the supply chain. So the first use case starts right in the factory with automated robots with heterogeneous networks and foresees the use of 5G-enabled multitask automated robots for the future smart factory production lines. And after the goods are produced, they have to be transported. So the second use case focuses on the transportation of the containers full of goods, and it pursues the asset health tracking in order to decrease the operational cost and keep all the goods monitored during all the transportation in real time. Once those products arrive to a port in order to then be transported by sea, the next use case is in the port entrance, where the use case aims to, with artificial intelligence, to monitor the access of vehicles to ports and reduce the waiting times. After that, the containers are load and unload to ships. So the next use case is covers the safety-centric part of the port, in which through tactile internet and edge computing, we aim to keep the employees safe and away from hazardous working locations. Then once the goods are already loaded into the ship, the next use case covers the transportation through sea. So we need non-terrestrial networks like satellite connectivity to keep monitoring of the goods through their transportation by the sea. And the last use case of the project integrates all the steps of the supply chain and aims to ensure that all the exchange of information that is needed to monitor all the transportation and in real time is exchanged in a secure and trustworthy manner. In order to ensure that all these use cases can be performed, we need a cross-layer architecture that integrates the different and very varied technologies that are required to perform the ambition of the project. This architecture covers these emerging technologies and something that is very necessary right now, that such as artificial intelligence and machine learning across all the layers, and security and privacy aspects are also covered for all the layers of the architecture to interconnect and communicate to perform the ambition of the project. And finally, in order to test all the innovations that are intended to be performed during the project lifetime, we aim to do the trials in 4 different use cases, in 4 different test beds that are real environments in which the supply chain performs. The first one is the ASTI factory, that is a robot manufacturing company in the north of Spain. And the second test bed in which the trials will be performed is a ship of Costco, to prove to validate the use case of the asset tracking during the route within the Mediterranean Sea. In particular, the ship will be traveling from the port of Valencia in Spain to the port of Piraeus in Greece. And a third test bed would be the port of Valencia, not only for being the origin of the Costco ship trip, but also within the port facilities. Some other use cases will be tested, such as the driver safety use case, in which an AGV will be remotely controlled to transport some goods. And finally, the last test bed in which the project will be validated will be in Livorno port in Italy, in which we will validate some use cases, such as the truck flows optimization of times, and also the supply chain integration use cases. So that's all from my side. And if you want to know more about the project, you can ask later in the panel.
Thank you very much, Nuria, and great to see some other projects related to port and logistics. We actually have some in the industrial 5G testbed trial as well. So we have come to the end of this first round of presentations. And I would like to thank our speakers so far. And now it's time for a panel discussion where we're going to talk about how 5G can help accelerate digital transformation in manufacturing and logistics. During this session, please feel free to post your questions in the Q&A section, and if time allows, we will try and answer as many as we can at the end of the discussion. Please welcome our panelists today, and chairing the panel we have my colleague Claire Caminad, who is the head of 5G product and partnerships. Please, I would like to invite now all the speakers and Claire to your screen on. Claire, I'm gonna let you. Nice to have you all. I'm gonna let you introduce the panelists. Thank you.
Yes. Good morning, everybody. Welcome for this morning about industrial 5G. So without further ado, I'm going to ask all the panelists on my panel to switch on their video. And please introduce yourself. Maybe Mark, you want to start?
Yeah, sure. Hi, Claire. Morning, everyone. Mark Funnell from the National Composite Centre. I'm the Director of Digital Engineering, one of our newest business units, where we're looking to explore the application of digital technologies and how they can support engineering, manufacturing, and we've currently implemented the 5G Encode program, which I'm happy to discuss in a wider forum during this panel conversation. Lovely to have you.
Thank you. Karen, do you want to introduce yourself?
Hi, my name is Karen Poulter. I'm head of IT for Hutchison Ports UK and also CIO for Europe division of Hutchison Ports. And we are the lead consortium member for the 5G Trials and Testbeds 5G Ports project.
Thank you, Karen. Next, Paul.
Thank you, Claire. Morning, everyone. My name is Paul Butler. I'm the Chief Executive at the North East Automotive Alliance and also project lead for the 5G CAL project.
Thank you. And last but not least, as always, Chris.
Yeah, good morning, everybody. So my name is Chris White. I'm the electrification manager for Ford Manufacturing Engineering here in Europe. And I'm also the project lead for 5GEM, which is 5G enabled manufacture.
Thank you all. So without further ado, let's start with the first question. And I wanted to jump directly in the heart of what you're doing. So you're currently all participating in programs around 5G and trials where you're trialing specific use cases. What I wanted to ask you is, what are the business challenges that you're trying to address with these trials? What were your assumptions about the impact of 5G solution before the start of the trials, and what results have you achieved so far with the trials? I know the trials have not yet finished, but you probably have some first results to share with us. So who would like to start? Karen, would you like to
Sure.
give us your view? Thank you.
So we're looking at two ports-based use cases. The first is remote control cranes over 5G. So we already have remote control cranes on port, but they rely on a not ideal networking connection approach, and we are keen to explore 5G for this in order to extend the use of automated technologies on the port without having to dig it up. So that's the first, and the second is IoT-based predictive maintenance of key cranes over 5G. This is an interesting one because what we're really testing here is the ability to run these two very different use cases concurrently over the one network. And the reason that's so important is because in a port environment, the chances are we'll have a great deal of IoT sensors, and 4G doesn't have the capability of maintaining the number of sensors the port would need. What the business benefits to both of these are to save money and drive up consistency of productivity. So saving money from the predictive maintenance part, because the better we can maintain our very expensive assets, then the more cost efficient we will be, and the less our business will be interrupted. And also from a remote control crane perspective, there's obviously a use case for that in itself, but to do that over 5G means that we can extend the technology without further interruption to the business. Where we are is that we are transiting data at the moment for our IoT sensors, but we've yet to run those over 5G. They're coming, 5G is coming online this week. And from a remote control perspective, we've trialed that technology in the lab, but we have found some issues. Our Siemens PLC appears to favor version 16 of 5G, and we're running version 15. So I think certainly what we see from an industrial perspective, IoT is not 5G ready yet, or the devices that are coming online now are 5G native, but that has been an issue. And in terms of whether some of these very high latency, low latency, sorry, industrial uses are probably more suited to some of the later versions of 5G. That would be our initial findings.
Thank you, Karen. Very interesting. Chris, maybe you want to share also what is the purpose of all the trials you're running?
Yeah.
And what assumption did you make before the start, and what happened?
Yeah, so I guess the sort of high level business case of Ford is, we have a large number of connected factories. We've made things like engines and transmissions for a very long time, with lots and lots of machines all hardwired and getting data from those machines to understand what's going on in our facilities. But of course, we're facing a revolution in our industry as we move towards electrification. So as we start to build factories that will make e-motors, batteries, we're going to change our footprint in a kind of revolutionary way in the next 5 years. And as we do that, it's a great opportunity to think about how do we want to do things differently. And one of those is how data flows within the factory. And ideally, we would like to do that wirelessly. And of course, in greater volume, with more data coming from the shop floor. So 5G is certainly a solution we're looking at. So that's why we started the 5GEM project. and we've connected some machines that we have in our pilot plan that do some of the key operations around making electric vehicles. So whether that's welding copper in an electric motor, or whether that's welding battery terminals into a battery, we've got both of those solutions now connected under a 5G network in partnership with Vodafone, and we're working to take that data away from the machine and process that data and understand what opportunities we get from using 5G to do so. We're also using the 5G network to allow remote experts to access the facility and understand what's going on in the facility, and also a little bit, as Karen said, to drive maintenance activities using things like HoloLens and headsets. So we developed the network. We've been running for a little over 18 months. We've learned an awful lot about 5G and networks. The quality of devices and the type of network that's available has moved very quickly. So we've learned a lot more about what we need. I wouldn't say that what we have today is what we need, but we've learned an awful lot in that journey about what we need. I think, as one of the speakers was saying earlier on the 5G CAL program, upload versus download is a significant issue for us. Device availability is another significant issue for us. But probably, taking it to a kind of a more big picture level, actually, once you get the data, and 5G just enables us to get more data, what do we do with it and how do we handle it? What are the standards that we're going to use to control and manage, an amount of data which would have been unbelievable 10 years ago? How are we going to manage that? And kind of almost we're tipping over, fixing one problem, but we're very much starting a new one.
Good point. Paul, maybe you want to share also the specifics of your trials in the Northeast.
Okay, yeah, thank you. So across the Northeast, we are undoubtedly a beacon of productivity. With Nissan supply chain, they have a continual drive for operational efficiency. And the 5G CAL project was just a natural progression of innovation activity around logistics for some time. So going back to 2007, when Nissan first looked at indoor AGVs, they've now scaled the deployment of that across the facility. They've then looked at outdoor AGV, looking at units with an 8-ton towing capacity to be able to move product between various shops across the plant. The next natural progression was to look at automating the deliveries from near-side suppliers. So within 2 miles of Nissan, there's 11 suppliers doing about 1,000 deliveries a day. But key to that drive was to look at how we could remove the safety driver from the vehicle. Most connected autonomous mobility solutions will have a safety driver in the vehicle, and that defeats the purpose of what we're trying to do, which is about reducing cost and driving efficiency. So without 5G, we could not have done this project. As Richard explained earlier, we absolutely needed 5G to deliver the low latency required in order to take control of the vehicle through teleoperation if it came across any abnormal condition. So it's definitely not something we'd have been able to do without 5G.
Thank you, Paul. Thank you. And Mark, would you like to explain also your project and what were the impacts you were looking to achieve and what have you achieved so far?
Yeah, sure. Thanks. So yeah, the National Composite Center is a research, or it's an RTO essentially. And at the crux of it, what we were doing was expecting 5G to offer certain flexibility, robustness, reliability, low latency, high bandwidth kind of throughputs. And that actually has been proven. I think Chris mentioned, the difficulties between upload and download. That's definitely an issue we're facing. What we have is 3 key use cases. One around very high bandwidth kind of flow, which relates to expert helpers, VR, AR applications, the augmented working within a factory kind of setting. Plus, with the move to more hybrid working, how we make sure people that are external to the factory can actually engage with factory assets in the right way and sort of think about that remote working, remote interaction with machines from an offsite location. So there's a number of security protocols which we're interested in, what 5G can offer with private networking and ensuring that that one-to-one relationship with the factory is available, and it requires very much the high upload and download capabilities that we were pushing for. We're also exploring low latency use cases, so immediate feedback to machines, and we use the terms hot path and cold paths. So we really, our hot path is at the edge. How do we make sure that closed loop manufacturing, that concept where the machines can self-adapt based on stimulus and interaction with the process itself, so moving away from just simple control systems into massive machine connectivity and the ability to have all these data sets. How do we get intelligence from this data and actually codify and putting the algorithms in place for machine learning and interactive feedback with the machines. And we're developing those on liquid resin infusion at the Composite Center. So we have a factory facility. It very much is a large scale facility where we have machines that we're testing these use cases on. And the third aspect that we're looking at is related to that in-factory and out-of-factory sort of asset tracking, linking to the logistics. Now, we're not focusing on logistics. We're more focusing on how information transfers from a factory private network and potentially into the public networks, and how that transition would work. And what we would need to manage in terms of the translation of information about asset movement within the factory to optimize flow, but also to look at how we monitor and manage it outside of that factory setting. So those are our three core use cases, and each of them have different criteria that we're looking to invest on behalf of industry. So the NCC itself will be looking to scale up its 5G use cases into something that's relevant for our own operational performance. But really what we're trying to do with our program is create a very much an open test bed inside a factory setting. And Karen mentioned a lot of information about the IoT devices. We see that. We were very shocked to find how difficult it was to find the right skill sets within our IT organizations to actually implement some of these assets. So we've chosen not to go with a vendor, an end-to-end solution. We've actually chosen to keep it as much open as possible in terms of the Open RAN. We are able to connect with multiple devices, or at least attempting to connect with multiple devices. So we have the Siemens products, we have off-the-shelf kind of small vendors coming to the table, and we would like our 5G testbed to be just that, a trial for technology providers in the IoT CPE space, which is where we see the shortfall today, to be to offer them that platform to come and test and scale up their assets so that they can put them out in the market and sort of broaden the scope of technology that's available to industry. But also at the same time use our factory to demystify what 5G is actually all about, what can it actually offer. And we've done the comparison between Wi-Fi, LoRa, 4G and 5G as part of our exercise to really help us understand what it takes and to help industry therefore learn from us potentially so that they can take their first steps on their own 5G journey. So we see us as much as that incubator and that pull through of technology and the ability to support industry on their uptake, essentially. Okay.
Thank you, Mark. Thank you. So my next question is about the unexpected findings. Is there any things that you've discovered during this trial that you didn't expect? And I know, I believe, Karen, you have some experience to share, and I think Mark already touched on the CPE, but Karen, you may have something you would like to share to anybody wanting to try 5G nowadays. And
yeah, sure. I suppose the one thing that we found that I wasn't expecting was that there were certain constraints, certainly at the outset of our project, around things like spectrum, that in turn influenced what we were able to do with 5G, the power of the kit we were able to use, the power of the power of the signal, which did alter our use cases. So I guess when we started this, I thought 5G was probably fairly plug and play, and my experience is it is not plug and play. And it's similar to Chris, we're using the unique bandwidth capabilities of 5G for our remote control cranes, but again, we're using them as high upload, not high download, and 5G is typically it's tried and tested for its great download speeds and bandwidths. But some of these things that you think are, I thought it would have been much more of a thing you decide you're going to do and you just do it, but it's not like that.
And I think even, the journey of, it's a great point, about just plug and play, the journey of getting a network up and running has been interesting, shall we say. You know, our providers are learning, we're learning. You know, in a factory environment, I'm charged with being able to move machines and production equipment, you know, in a weekend. And if that 5G network infrastructure is in the way of that, then I need to be able to move it too within a weekend. And at the moment, what I've got is not capable of that. It's not a, you know, it's not a modular solution that you just pick up and move. It's kind of been built on site. It's, you know, it's been built around our solution. And I know that Vodafone would say very clearly that, you know, that was their learning and they've moved on. But right now, you know, the state of the technology is that, you know, it is kind of built bespoke around your facility. Over time, I'm sure it's not going to be, but it definitely, you know, that's been a surprise learning for us.
Thank you, Chris. Thank you. Paul, would you like also, or have you come across also unexpected findings?
Yeah, I mean, similar to both Chris and Karen in terms of the infrastructure, but I guess one of the unexpected findings from our project is the potential use cases around teleoperation. So that was very much a byproduct to enable autonomous logistics for our project, but actually that's probably where the biggest opportunities are for commercialization of the solutions we're providing. So we've identified other similar use cases around port-centric logistics, around airports, rail hubs, distribution centers, and we see huge potential to be able to deploy that teleoperation solution in those type of controlled environments.
Nice, a positive finding. Nice, thank you, Paul. And Mark, any unexpected findings you came across during the trials?
Yeah, I think I'm going to be more with Karen and Chris on this one. You know, our biggest issue was we were trying to not make 5G or feel like 5G as a brand new piece of technology that is absolutely going to fundamentally need a rework. But in a lot of instances, you know, our IT teams, which you would expect to essentially pick these things up and essentially just plug and play them or install them without too much pain, that's not the case. And if you look at production situations and how factories operate, your business as usual kind of IT organizations, they just don't have the skill sets today. The technology doesn't seem to be as simple as we would have hoped, which is fine. You know, we didn't expect them to necessarily be plug and play, but I think we're almost retrofitted a brand new network in order to accommodate the kinds of speeds and situations around, you know, slicing and splicing that 5G offers. So we actually do have two networks now. We've ended up with a 5G development network, you know, and we actually have a production network which runs most of our machines. And there's a very controlled mechanism by which we will upgrade our networks. And as we roll from that, you know, development environment into production environment, and that whole process, I think, was something we learned and was a bit unexpected. So we put in brand new change processes on how to evolve, you know, reliable networks into production environment. On the positive side, you know, our 5G, you know, while it's an open and it's built off different components, you know, it was difficult, and we have a lot of open RAN technology going in there, and our providers are learning a lot with us. But the system actually works, you know, and we've managed to test all our use cases. So it's fantastic, albeit it's a little bit throttled back at this stage just to make sure we keep stability on the network, and we're slowly going to throttle it up to the point where we can get 1 megabyte upload speeds. And I think the point about upload is a really key thing that people need to focus on. We need uploads for high definition data coming off of manufacturing shop floors. It's a lot of video, there's a lot of information. The upload speeds is key. Okay.
Thank you, Mark. I mean, I'd just like to maybe reassure our audience. Obviously these are R&D projects, so obviously this is all what it's meant to be, to discover and uncover what you don't know, and all positives and negatives thing, obviously. And I have to say, to go with Mark, the skill of the teams in the manufacturing environment or industrial environment in general. Because we've been involved in several projects, Digital Catapult, and we've seen that issue time and time again. And it's not to be, I would say, you have to really take it seriously. It's what we've seen. People are quite dismissive and, oh, okay, someone will do it. No, it's really, really a big block, and you can't convince someone who is in IT who doesn't understand what you're going to put in his network to just, oh, don't worry, someone will do. No. They know that all hell will break loose if ever the whole thing goes wrong, and it will be on their head. So they want to have an understanding what is happening here. And we know that cellular technologies are different from the Wi-Fi or fiber technology. So thank you very much for all this feedback. So now I wanted just to look at the future, and so the trials are supposed to be finalizing by March 2022. There might be some extensions, but what's your view? So are you looking to deploy at scale? Are you looking to trial more? What's going to happen with all those trials? So maybe Paul, you want to start?
Yes, thank you. So subject to a successful proof of concept, we're looking at a number of different options to firstly scale the solutions across the existing trial route. So as Richard mentioned, there's about 100 deliveries a day on that single route. There's 13 HEVs in operation. So we're automating a single unit. The plan will be then to scale that up to look at 13 on that route by 2025, but then also look at taking the technology onto other routes as well. So we're looking at a more complex route, which would encounter traffic lights, roundabouts, security gates, bridges. So a much more complex route for the autonomous system to be able to operate on. And then also looking at other potential routes, deployment within one of the Northeast ports. And it is a very different challenge because the where it would operate is basically a massive expansion of concrete. And the vehicle has a very different challenge in terms of being able to identify the directions from which traffic could come, and it's anywhere. So there's no road infrastructure in place, so it's a very different challenge. And the idea is, as we're developing the technologies there in more complex road infrastructure and then these open areas, it really will enable us to accelerate the TRL levels of the software solutions to a point which will move us quicker towards getting onto public roads. But as I said, there's many opportunities to look at some of the these controlled environments in the first instance, where operating on private roads initially.
Oh, sorry, I'm on mute. Thank you very much, Paul. Quite ambitious future. Really nice to hear. Mark. It's a bit special. It's a bit different from the other trials, the trials you're running. So, what are you looking to do?
Special, Claire. We're special. So for us, the journey is, as I alluded to at the beginning, we like to operate our system as that open RAN, open access testbed, which means we're going to keep as much flexibility and as much open opportunities, both from a software development perspective, but also from a hardware kind of operational technology, CPE integration. So the NCC will open its doors post the program to invite technology providers who are coming through, who have tested them in a lab environment, and to allow them to bring them into our test bed and test them in the Faraday cages that are a factory. And we've successfully connected with 4 or 5 different vendor solutions, some successfully, some not so successfully, and they've gone back for more development. So it'll be about maintaining that philosophy on our test bed on one side, creating that flexible open access trial location for the technology providers. In a second sense, it's really about us expanding the places we install 5G technologies. So we will be looking at hybrid working as a prerogative. We will be extending across and outside our sites to be able to see how people outside of a factory scenario would be able to integrate, looking at private networking and the security protocols behind that. We also, taking Paul's point, we're also looking at air-to-air communication, trying to get away from the underground fiber networks. So that'll be part of our developments. But yeah, I think for us, 5G offers a flexibility. Chris's point about moving away from wired is really where we see the benefits of these radio solutions, allowing us, especially for small or medium enterprises where you have very costly sensorization and vision systems, to slowly move those around the factory so you can use them in different locations without having to worry about wires and all the bits and pieces. So it's about exploring those themes with our 5G testbed. So we'll be looking at Q1 of next year, as while we close off the program, to really start to launch a campaign around how we would invite and entice technology vendors as well as industry innovation services for people to come and use our testbed, essentially. Okay.
Thank you, Chris. So what does the future look like for Ford?
Well, I guess one of the interesting problems that I have, perhaps not everybody else here has, is we need to inform a global strategy. So we need a solution which will work in every plant in the world we operate in. And at the moment, there are differences in the way that people are approaching wireless communications. So CBRS is very popular in North America. There's lots of discussion about Wi-Fi 6 and the benefits you get from that. But equally, then you kind of look at how networks are deployed, whether you build your own network, like Mark talked about, and you buy your own spectrum in your particular industrial area. We've got plants in Germany that have done that. The licensing and managing a spectrum is all very different. So how across all of that are we as Ford gonna have a global wireless strategy, which kind of meets what we see coming towards us, which is more and more our factories are producing more and more data, and in some cases, the solutions we have just aren't managing or aren't coping. So kind of that's where I'm going to spend a lot of my time in the next year or so. For the facility itself, it's very much like Mark talked about, the quality of devices that we're seeing and the opportunities now and the interest we're getting from the people that we work with is increasing around 5G, and we're obviously here and ready to start trialing those devices. Absolutely, as Mark said, some have been not successful, some are more successful, and increasingly, more plug and play stuff is arriving. But we also have, things like suppliers of electric screwdrivers. We use hundreds of them across our assembly plants. They're all transmitting data back about, every bolt they tighten up. But at the moment, most of that is either wired or Wi-Fi. We need to start understanding how we're going to create the business case for suppliers like that to put a 5G chipset in that tool. It's significantly more expensive, and at the moment they don't necessarily see the pull. So we need to start working with the supply base, if you like, to understand how they'll make that transition.
Very interesting, very interesting. So yeah, a lot on your plate, and definitely again the CPE issues coming around. So maybe good thing with Mark to first program to start. And Karen, so what does the future look like? Will you keep on trialing? Are you pausing, or are you going, that's it, convinced we're going to go full scale?
Well, I think we're a slightly different story to everybody else's in that we currently have an aging 4G LTE private network that's critical to our business and our operations. And we've got a decision to make, which is about a full-scale refresh of that or a transition to 5G. And my preference would be to transition to 5G. But we obviously as I've already alluded to, at the moment it isn't quite industry ready enough for me to be able to confidently recommend that that's an appropriate commercial venture at the moment. One of the struggles we also have is that clearly the 4G LTE network is business critical. Refreshing that comes at cost A. Refresh or moving to a 5G network will come at cost B, which is likely to be higher. And for our business, and I think every business out there, we operate clearly on ROI. So yes, the things we're proving, certainly remote control cranes over 5G definitely cannot work over 4G, but there has to be more. We need more developed functional business cases that will that will push us over the edge to taking 5G, making it work. Because like I say, I don't think it will be as easy as it was at the point that we adopted 4G. So that's kind of, for me, the future is 5G. The challenge is the business case for 5G. But we do have this almost lucky area, which is that we have to do something around our existing network. And that kind of, we will obviously spend to ensure business continuity always. So there will be some spend there. It's just whether we can justify the extra and whether 5G is ready to pick up the pieces.
Thank you. Thank you. So I'm going to project everybody or in distant future where, or maybe not so distant, where you have the fully deployed and up and working 5G solution in your factory or on your test bed. And what do you see during operation and maintenance of a solution would be the challenges, and that we need to start thinking about that? Chris, maybe you would like to chip in?
I suppose very much a kind of operational level. You know, one of the things that's kind of good from a security perspective is, you know, every device has a SIM, so you've got that security. If somebody's got to put it there and you know, that's the only way it's going to communicate with your network. So that's a strong security aspect. But practically, you know, if we've got all these devices on our floor, how are we going to manage all of those and make sure that, you know, we maintain them properly? It becomes a skill, and, you know, a level of management that we don't necessarily have today. It's incredibly valuable to have that out there, but we'll have to think very hard about how do we control, you know, the network and what's on it, and if it's not working, who fixes it? You know, there's a new set of skills out there for us, really.
Thank you, Chris. Mark, would you like to add something?
I think that's great, Chris, because, you know, if you look forward and you say, right, you have cost is king when it comes to operating a network, and I'll be a bit crass and say IT is considered as an overhead. So, you know, if you're going to bump up the costs of operating that network, then we're going to cause a concern for implementation and adoption. So we need to look at trying to get products out in the market which can reduce the cost of entry and therefore bring them into that operation environment. Plug and play, I think, is the nature of what we're trying to get to. So really trying to get that market sorted out through these test beds and trials and continuing that development is a key part of the sustainment. Making sure our people in our IT business as usual organizations are upskilled, and that's going to be a big part of the test bed program that we run from the NCC perspective, is to try and make sure that those IT people who will need to operate that network are not necessarily a step change from the business as usual IT team you see today, but we help them develop their skills and capabilities. And then associated to that are the tools and technologies that will help you manage your network. So we work with our lead partner, Zeta, who's bringing a number of orchestration monitoring solutions, which actually decrease the barrier to actually monitoring and maintaining these networks. And that's a journey that we will go down, is how do you decrease the skill set? When I say decrease the skill set, how do you keep it to a point where you don't have to have PhD kind of level students, PhD level people to actually run this network? And that's where a lot of the software management monitoring systems, we have a new partner, Sadian's joined us, looking at how you'd monitor the network, Chris, so we can have maybe a chat offline about how we're trying to do that, because we see that and all the security issues around all these multiple sensors will be embedded. And we're starting to talk with NPL around how we'll actually start to manage data and resilient data sets and the standards associated to those test beds. So all of those are absolutely fundamental to move us from a perspective of it's a trial into an operation environment, but cost is king. We cannot have a point where we need a 50-strong IT organization with fiber everywhere, and it's going to take us a time. It's really trying to decrease that barrier for research, and come back to Karen's point, that's where the return on investment will be. And that's where I think the trials and test beds should be taking us, really unlocking that cost barrier, essentially.
Thank you. Thank you very much. I just wanted to ask maybe a more philosophical question around the adoption of 5G. Like new technology, 5G will go through a curve, an adoption curve from, we know the infamous one, adoption curve. We are at the very beginning with 5G. In your view, do you think that 5G adoption is any different from any other technology, like artificial intelligence or I don't know, blockchain or IoT or immersive technologies, for instance? So do you think it's the same and it's going to go through the same difficulties and the same success stories? And or do you think there's something particular to 5G and the adoption of 5G? Mark, do you want to start maybe?
Yeah, I think for me, the 5G hardware is the key thing. So when I look at artificial intelligence, blockchain, they're technologies which maybe I don't know them too well, but they're pretty much software orientated and they've been out in the market for a while, you know, and you know, while I might be talking, you know, data science has been around, it's just been turned into different names as we go through the years, you know, so the ability for us to use algorithms effectively, financial industries are using them day in and day out. It's basically just jumping across. For me, you know, the step change between 4G to 5G has been quite interesting. I think their hardware is different. The whole radio spectrum thing is different. So it's really, for me, the key changer is not, I know the software is catching up, but it's the hardware implementation and the changes you need to make to those physical assets that is causing a little bit more of an adoption issue than probably what you'd see for some of the software where you can throw developers at the problem. In this case, there's that hardware aspect which we need to really be considerate of.
Thank you. Paul, in the automotive industry, there's quite a strong story about digital adoption. How do you see 5G adoption compared to these other digital technologies?
Well, it comes back to everyone's point around the return on investment. 5G is a technology enabler. The business case for putting 5G infrastructure into a manufacturing facility, there's no immediate return on investment unless there's a true use case for that technology. So you've got to work with businesses to understand where these use cases are that require 5G and the unique characteristics of 5G to be able to prove the technology, prove it works. And once you've got that installed, then it does open up a lot of different opportunities. So for me, the 5G CAL, the connected autonomous logistics piece, is a commercial use case of 5G. And once that's installed, then businesses will look at that and then start looking at what other use cases they can look to develop in that area. And once the infrastructure is in, it's much easier to put together a business case for those specific use cases where you can demonstrate the return on investment and the efficiencies that it will drive.
Thank you, Paul. I'm conscious of time, so I'm just going to ask you a last question before we jump to the Q&A. If you had to share your view in one sentence about 5G for industry, what would it be? Chris?
Okay, yeah, I mean, I'd build on the point that Paul just made. 5G is a technology enabler, so we have to stop seeing it as, you know, you asked, where is it on the innovation curve? Well, the innovation curve applies to the technologies we want to enable, you know, whether it's IoT, whether it's augmented reality, artificial intelligence. Those are the things which will grow in that curve. 5G will help it get, you know, part way up that curve, and then maybe there'll be other technologies that'll take it all the way through to full acceleration. But it's just one of the enablers. Agreed.
This is one of the biggest challenges to my view, is that it's an enabler, and if you haven't thought about all the whole stack, it's not going to work. Karen, what's your last message to the audience?
I think my message would be that 5G is undoubtedly going to be very, very important, but it is exactly the same message as everybody's already said, which is that 5G isn't it's not what we're striving for. We've broken the number one IT rule, haven't we? We've stopped talking about what the business problem is and start talking about the IT solution. And actually, maybe it's more about really focusing on developing these use cases that we're talking about. Particularly, I know manufacturing probably further ahead of the curve, certainly than the ports industry, but we're all talking about similar things around automated technologies or remote control technologies, trying to be more efficient. I think it's pushing those use cases so that the use cases become the business solution, and 5G just becomes what has to happen. I do think it is undoubtedly going to play a hugely key role in all of our businesses, and we all want to be on that train. But yeah, we got to. It really is about what the functional point is.
Thank you, Karen. Thank you, Mark.
Yeah, I'll try and do it in 1 or 2 sentences. We've all been through the pain. Come and talk to us about what we've tried to do, because you can get a lot of learning. You don't need to repeat the same exercises. We've all got good use cases, and I'd suggest they're fairly similar, because it's absolutely about the value that this enabler unlocks. And if I can leave you with one note, is 5G, while a great technology, there's also other technologies on the market which can support flexibility. So when I talk about 5G as a holistic network, you know, you're talking about all potential applications from LoRa all the way through Wi-Fi to 4G to 5G, which are the network enablers and the communication enablers for us to unlock value within our industries and environments. And I'd suggest that we've got a lot of learning on that journey. So do come and have a chat.
And Paul, what would be your final words?
Very similar to everyone else. I mean, in terms of the automotive sector, we are highly automated. We're highly efficient. Industrial digitalization is undoubtedly the next step change in terms of operational efficiency. 5G will enable that and be a key enabler. So we've got to work with industry to support them to build the business cases for that investment in 5G. We're fortunate here in the Northeast that across the Sunderland City region, we've just announced there's a partner, BAI, have come in, and they will be a neutral host provider for 5G across the city centre and the citywide region over the next 20 years. But we then need to start working with industry to identify where these opportunities around digitisation are. And I think there's an awful lot of learning that can be shared and developed as a network. So working together so we can avoid these costly mistakes, working together to share the learning is going to be key to everyone's success around this area.
Thank you. Thank you. Let me just have a look at the Q&A. So it's a question from Dick Wallis. What steps, if any, are you taking or recommending to register IP for world-leading UK 5G IoT breakthroughs? Or would it be more advantageous to UK PLC to share these breakthroughs with as many countries as possible, as port blockages and so on are life-threatening? Who would like to answer that question?
I can have a go. I would say any IP at the moment that's within the project is being by the nature of the agreements that we went to at the start of the project for the commercial partners and the people that are developing that's under their ownership to do with as they see fit. But what I would say about it is actually there's kind of, when you come to port-wide or global logistics changes, I think actually 5G IoT is quite key to that, because there's certainly a lot about tracking logistics, tracking movement of goods, understanding where things are in real time that we haven't really got a handle on. But actually there's a problem before that, which is around data sharing. So as with all industry, data is power, and there are an awful lot of different we have shipping lines, we have hauliers, we have port operators, we have lots and lots and lots of different people who've got a hand in this pie, and they all take part in the data sharing around that. So I would think there are undoubtedly technological solutions that will help to drive efficiency through logistics. I think some of what we've learned throughout the course of this year is that there's probably and I do wonder actually if maybe we have seen the start of a change of, or at least a realization of how interdependent we all are from a logistics perspective, and how fragile that is, how much it relies on free flow, but free flow relies on free flow of data. And I think, as with all industries, there's still a way to go before everyone decides that there is a greater good around being completely transparent about where things are and what's happening. Not necessarily a technology solution to that problem outright.
Hello. So thank you, Karen. There's another question for you, actually. So it's a question for Karen. How do you see the capabilities of a private or public 5G being shared across all the different business entities that operate inside a port? Could also apply to airports.
Yeah, so I think actually one thing I didn't mention, there's also free ports, which obviously is a big topic at the moment in the UK. I think just using the Freeport East example, which is Harwich and Felixstowe. So there is part of Freeports is creating these innovation hubs, which sounds sort of akin to, obviously on a very much smaller scale than the kind of stuff that Mark's working on, is generating an environment where companies are coming together, and part of that will be to provide networking facilities for them to do what they want to do. I think there's a unique complexity between sharing the port's private 5G network, because by its nature and the fact that we're CNI, and that's that is a very protected thing. But I do think that the Freeport transition of data across partners within, to be fair, today within the port boundary itself, probably outside of data exchange that's dealt with purely through shared systems, there isn't probably a great deal of shared use of that kind of thing within the port environment. But I do think maybe Freeports on a mini scale is kind of a little bit of what we talked about in the answer to question 1, because the success of the Freeport, certainly when custom sites start to exist beyond the boundary of the port, and you have to start to work across different partners to transition those goods safely and securely and with traceability, you will start to see more sharing of data and more sharing of networks to enable that.
Thank you. Thank you, Karen. Thank you. I think we've come to an end to this panel. I would like really to thank the panelists and the time they've taken to prepare and today for the panel. I believe some of you, Chris, Paul, Karen, Mark, will be in the networking session. Otherwise, I believe people are completely free to contact you if they wanted to know a bit more or explore some new things with you. Thank you very much, and to the audience, enjoy the rest of the morning.
Thank you.
Thanks, everyone.
Thank you.
Bye.
Thank you very much, Claire, and all our panelists. Very, very exciting discussion, and we look forward to follow on their trials, and we will share with you as much as you can the learnings from those trials early next year. We are soon coming to the end of this webinar. And we're going to move on to Remo shortly. We know it will not be the same as an in-person event, but we are pleased to offer you the opportunity to virtually meet. And we'd like to thank our colleagues at UK 5G and Cambridge Wireless who have helped us to make this possible today. If you have not received the link, you can also find it in the chat. And just to kind of give you a very quick overview of how this space will look like. You can see there is an area for help if you've got any problems, but you can find basically tables where you can meet either in peers, in a group setting, or one-to-one. Each project has got a table. You can also find a table for meeting KTN to discuss funding opportunities, and also UK 5G. And I will be at the Digital Catapult table with my colleagues, so do pop by and say hi. It's very easy to use. Simply double click on a seat to join the table, and switch on your camera and microphone. But my colleague Lara will be there to make a quick announcement after you join to provide a few instructions. Before we close the webinar, I would like to invite you all to join us at the next event on the 18th of January. This is where we will share technical lessons learned and innovative solutions that have come from the industrial 5G testbeds and trials. And time to say thank you. We hope you have joined this webinar. A big thank you again to our speakers today and panelists who have shared their experience and insights. We hope to see you at the next event on the 18th of January. And from me and the Digital Catapult team, a big thank you for all for listening. And see you shortly on Remo. Thank you.